Okay, well, I'm Janice Mack. I'm at Arizona State University, and I'm really excited to present this to you. I'm also co-chair of the Computational Practices in Science rig
Mm.
that just launched this year at NARST. So we're really excited, and this is one of the events that's associated with our new rig. And I will pass it over to my co-presenter, Josh.
Hi, Sarama and Lauren. My name is Josh Rosenberg. I'm a faculty member at the University of Tennessee, Knoxville, former science teacher, interested especially in data. So a nice compliment to Janice's slightly greater focus on the computing side of this work. So
Oh,
interested in
thank you.
data and science education and teachers supporting their students to use more authentic types of data. Sarama, over to you.
Uh, yeah, I'm fine. I'm doing well.
And your name and maybe your affiliation.
I was affiliated with Mumbai University, but at present I have retired from my job because retirement age here it is 68.
Thanks, Sarama and
And,
Lauren.
mhm.
You could
Hi.
not hear?
Yeah.
Hello?
Nope, heard perfectly. Yep, thank you.
Yeah.
Yeah, my name is Lauren. I'm on the opposite end of the spectrum. I'm just starting my career. I'm a graduate student at George Washington University.
Welcome. Is that everyone, Josh, that you see?
I think so.
Okay, good.
Nice
Awesome.
cozy
Okay.
group. Yep.
Yeah, so we will go ahead and just go through we'll sort of get started and then we'll stop and pause and have some conversation. But you can see where you can download the report right here. There's a QR code, so feel free to download that or read it online. And we are excited to present to you the Data and Computing in K-12 Education Foundational Competencies. This was a run by the National Academies and funded by the National Science Foundation. And the task was really to identify what competencies are needed for students to navigate and succeed in this computational landscape, but then really focusing on the role that K-12 education can play. So you can see here some of the questions that we were tasked with answering, thinking about what are the foundational competencies, how can these be enacted in the classrooms, and how can they be tailored to meet students' experiences, and what are the implications for K-12 curricula and the larger landscape as a whole? And then again, our study sponsor was the National Science Foundation, working and then commissioning the National Academies. This is our entire study committee, of which Josh and I were members. There were 16 of us, as you can see, representing a range of institutions and organizations, representing science, math, computer science, data, as Josh mentioned, all sorts of organizations. And so really thinking about the report is there's some key takeaways and why this report and how this report came to be. It was really thinking that, in K-12 education, there's been calls in recent years to integrate computer science, computational thinking, data science, data literacy, artificial intelligence, AI literacy, quantum computing. All of these things are, being asked and demanded of in K-12. And the concern is really like, this all could really overwhelm the K-12 system if not done intentionally and thoughtfully. And so that's really where this report came from. And then the other recognition is that, it may seem like there's all these disparate efforts going on, but actually, we thought, okay, there's actually shared competencies that perhaps undergird all of these fields, and that was our task to find out what those were. And then thinking about how now there is multiple paths forward, recognizing that we all have very unique contexts and landscape, but there are ways that we can take this forward, whether in kindergarten, whether in high school, thinking about how we can integrate, but also offer standalone courses. And we're building on, recent decades of research, particularly in data and computing. So the current context, there was a phrase that we used to describe the current times that we're in, and the phrase that we used is messy garden. There's a lot of great things going on. It just seems like we need to make sense of what's happening. And so the chapter 2 really talks about all the organizations, the initiatives, what's happening in the K-12 landscape. There's a lot of nonprofits, a lot of organizations, a lot of curricula, a lot of, they're all sort of advancing their own content, whether AI literacy, quantum, computer science, some of those ones we mentioned. And then there's a big challenge because there's only so many hours in a school day. In addition to everything else happening in the K-12 space, it's really difficult to find that time. But yet there's this tension because there is a growing urgency. We recognize that computing is everywhere, it's ubiquitous. We recognize the role that data plays in our lives, in our work, in our society. We recognize the role that Gen AI is transforming the way we're living and doing work. So how can we prepare students in this time? So this report is intended to meet this challenge. Again, as I mentioned, we're building on existing frameworks, and these are ones that are widely recognized and used in K-12 education by states across nationally. We have the computer science framework that was released along with the CSTA, Computer Science Teachers Association standards. We have the data science progressions that have just been released. Then math and NCTM, National Council for Teachers of Mathematics standards, Common Core Mathematics, and then we have, of course, the Next Generation Science standards, as well as the K-12 science framework that has grounded a lot of the work that the science community has been doing. I'm going to pass it over to Josh to talk about the foundational competencies.
Thanks, Janice. Do you mind can I increment the slides? No, I can't. So Janice, I'm happy to share if that makes it easier. I found this
Oh
in
yeah,
a
sure.
different
Yeah, let's do that.
presentation
Yeah, we'll
recently.
switch.
It's
Yeah.
always tough when someone's got their
Yeah,
kind
it
of,
is. And there's a lot of animations.
especially with animations. Yeah, I
Yes,
was doing
yes,
this just the other day in a webinar that
absolutely.
I was hosting, and I was like trying my hardest to be a good incrementer, but okay. So great. So part of the aim of the core task of the committee was identifying what are the knowledge and skills that underlie the messy garden of data and computing related competencies. And so there was no guidebook ahead of time about the nature or the number of these. And so this was a pretty iterative process. And through reviewing what was already out there, through engaging with foundational literature in data and computing, the committee identified 7 foundational competencies that are intended to provide some kind of loose but real kind of formality or structure to what the core knowledge and skills or competencies that underlie data and computing in K-12 might be. And so the competencies aren't strictly ordered, but the first 2 are good starting points to the 7 competencies. So the first is problem posing and problem solving. I'll go into depth on each of these here. So the first is an orientation towards solving problems and answering questions, namely starting with identifying an important problem or worthy questions, non-trivial. So it's pretty easy if you give kids a question to answer, or at least it's pretty doable. But when learners have to work through the process of figuring out what is the question that I actually want to ask, or what is the problem that I want to solve, and is it a meaningful one or a worth solving one? There's all kinds of problems in the world. What's one that's worth solving? That's much harder, and that's intellectually demanding work. So again, this competency involves figuring out what the problem or question is, developing some kind of initial plan for how to address it, generating some answer or solution, and then deciding what to do next. So the first competency is sort of a natural starting point, even though, again, these weren't strictly ordered. The second competency involves what I'll give a shout out to Andy Rubin on the committee, described as the process of turning the world into data. So this involves operationalizing. There's a big PhD level word there, but in short, turning some conceptualization into something that is, in short, measurable. For again, some concept or concept that we construct or concept that we care about, considering and gathering data that that maps to that operationalization, structuring data. So you might be familiar with the concept in like statistics and data science of tidy data. And this is a name for a particular way of structuring data such that every row represents observations and every column represents the things that you're measuring. It's very simple, but very powerful. It's actually easy to not have data structured that way and not really to notice it, where you might have uh, uh, multiple observations instead of being represented in multiple rows, but rather as multiple variables with something like measurement 1, measurement 2, measurement 3 as the different uh, time points that you measure something. That's not invalid, but it can make subsequent analyses more difficult than if you have um, 3 different rows in the data and then 1 column for the thing you're measuring, and then the value in each of those cells with maybe some additional column that identifies that those 3 come from the same, plant or unit or whatever the thing is that you're measuring. And then this kind of concludes with exploratory data analysis. So in short, competency 2 is about turning the world into data. The third competency involves fleshing out what it means to solve a problem or answer a question in a systematic way, especially when we have access to computation and computers. So this competency involves automating data and computing processes. You can think of this as being really closely tied to the idea of computational thinking. Fourth is probabilistic and inferential reasoning, which includes identifying sources of variability and uncertainty, carrying out statistical investigations and inference using estimation and testing procedures, and interpreting and generalizing results. So broadly, the fourth competency is all about modeling data. And this includes both traditional ways of modeling data, so things like the frequentist statistics that many of us are familiar with, t-tests, regression models, newer kinds of modeling, including machine learning models, models that have a different approach entirely, like Bayesian statistical methods, where instead of yielding a right or wrong answer, or not right or wrong, sorry, a statistically significantly different or not answer with respect to an alternative hypothesis and a null hypothesis, a Bayesian approach instead is about quantifying uncertainty. And so you can do similar analyses, but it's a different kind of machinery under the hood. And machine learning is obviously this way as well. So the fifth competency, it concerns modeling, but in a broader sense than in the previous competency. And it includes the statistical models, but it also includes other kinds of models, including considerations of being able to choose between different kinds of models given a particular context or goal, assessing their limitations, and recognizing the uncertainty intrinsic to all modeling efforts, those that involve data, like in the last competency, and others, like constructing physical models or diagrammatic models or computational models that aren't necessarily statistical or data models. Getting toward the end here, the sixth is important, and it focuses on tensions that arise when using data and computing in the context of human society or society and humans in the wider world. And these tensions have to do with values, ethics, and responsibilities, and putting those at the forefront of the data and computing related work that students do, not just treating them as potential sort of externalities to consider at some other time. Last, data and computing systems has to do with how these technologies, these ideas, data and computing can be used to solve complex problems. It also involves considerations of how to choose between tools given different criteria. So there's not one right tool. I was just in a research meeting where we were talking about using SPSS versus R to do some analysis. We were talking about, R is probably more flexible, but, it might be a little harder to do. SPSS is kind of clunky. You got to pay for it. Exactly these kind of decisions that professionals and learners can work through when deciding which tool to use. So it involves also considerations of whether a tool yields some analysis that's reproducible, or whether it's more of a one-off analysis, and also how well we could scale the analysis. So maybe we can do some work with data with 100 data points pretty easily with a tool, but could we do the same analysis if we had 100,000 data points with that same tool? That might require choosing a different data and computing system. So those are the 7 competencies, and these are meant to be the kind of touch points, with respect to how data and computing has and could play out in the K-12 curriculum. Janice, is this part me or do I hand this back
This
to
is
you
you.
here?
This is
This is
you.
me. Okay.
And yeah,
So
math and science.
so as you're probably expecting as science educators, there are significant overlaps between the foundational competencies and, for instance, the work laid out in the framework for K-12 science education and the next generation science standards. And so actually I'd love to pause here for a second and ask um, what reflections, if any, do you have on the 7 foundational competencies? Do you see connections to what's in the NGSS? Maybe you taught science before, maybe you do science education research now. Um, I'll actually, use this as a chance to go back to here, and I'll scoot ahead. I'd love to hear any thoughts on which of these resonate, which of these resonate less in your work as a science educator or science teacher educator, science education researcher.
Yeah, I'd love to start on this. Thank you for giving the opportunity to kind of reflect on this. I think for me, this is overwhelming in the sense of you showed a slide earlier where all of these are based off of and how many different things there are to pull from to kind of to make these. And so I think my question is, as a future science teacher educator, how are we going to get teachers to train on these things, to understand these things as either separate or the same as like the science and engineering practices from NGSS? Um, those standards are older now, so are these in a next iteration of NGSS? Are these things that could be or should be included? These are all really important
Yeah.
and they're all really different from each other, but are there too many of them? There's just a lot of that went through my mind with this because it's a really fine line, I feel like, between scientists are now becoming data scientists. Like the crossover is just so blurred that students really
Yeah.
do need to learn these competencies. But how are we going to train our teachers to do this is really where my head is at right now.
Yeah, great reflections, Lauren. Those are, I think, spot on and quite incisive. And things that the committee sort of started to discuss, but also um uh, uh, it's kind of my off the record take here. The charge of the committee was very broad, maybe overly broad, and so um especially connections to subject areas, specifically science education, Janice and my kind of home turf, we didn't get to flesh out those questions. Like what, for instance, what you said about like, is this meant to like be grist for a future NGSS? Yeah, I mean, maybe we honestly didn't get to talk about that. I think that was sort of tacitly or implicitly sort of the idea here is that these could guide sort of the revision of the next version of the standards. I know personally, when I look at the data related standards, they actually strike me as pretty good, but also all over the place in terms of it not being clear how something like a linear regression model, which is mentioned, I believe, in the context of some of the physical science, like high school level physical science performance expectation standards, like how do you build to that? Like it's not at all clear. It's not really laid out what like prerequisite ideas would help students to be equipped to, in a sophisticated way, interpret a linear regression when they're in a high school physics class. Or other times it's much more broad. It's like use a computational model in biology to model natural selection. Like what, which one? Like what, how, what like that's exceptionally broad. And so yeah, I see the need for more structure. So yeah, maybe Lauren, in 5 years, you can be um, part of an effort to think more critically. I love the way you put it about how like data science, computer science, how those are changing the nature of science and what that should change about how students learn. Couldn't say it better than you did. I tried, but I think those are the critical questions.
Well, keep me in mind. I'm graduating next year. So
Oh,
keep as you develop more committees, so I'll send you an email and keep me in mind.
there you go. Yeah, please do. Yeah, great. I mean, that's why Janice and I are sharing here is to have a discussion as well as to share about the work of the committee.
I am curious, did either of you just go to NARST in Seattle this year? Or are
I
you
did.
not in that world?
Yeah. No, I was there. Yeah, I
Okay.
know Janice does occasionally or often.
Okay. I
Yeah.
didn't get a chance to meet either of you, but maybe next time we'll meet in Boston
Yeah.
in person.
Yeah. So I
Yeah,
mentioned the computational practices rig that
yeah.
Mandy is on the webinar as
That's
well.
right.
Oh,
She and I are co-chairing that rig, so
oh, good.
feel free to, and this is an event tied with that rig, so just feel free to join us as well to continue the discussion.
Awesome. Thanks.
Yep.
Any other reflections, Sarama or Mandy? Well, I'll mention that Janice and I are beginning to discuss some kind of, I mean, this is sort of the first step, some kind of communication to our science education community about the foundational competencies and the report. And so, in addition just to sharing, we were also, I'll speak for myself, hoping to use this as a chance to sharpen some of the thinking around what about this is relevant to a science education audience. And so, If you have other thoughts, or here's the part I really want to say, if you are interested in being a part of that sharing effort on trying to communicate about the foundational competencies in the report and what it might mean for science education researchers, I'd love to talk further. We have a small group of kind of folks, some of them who were part of the report, others who were not. So you don't have to have been an author or a committee member to be a part of those efforts. So that's to say, Lawrence, Rama, Mandy, if you're very interested, we would at least like to talk about that and see if there's like an article we could share, either if an STA journal, a future conference presentation like at NARS next year, or something like that. So that definitely part of why we're sharing. All right, that thumbs up, I'll take that. Very good. Thanks, Mandy. Yeah, definitely collaborative about this. I mean, yeah, we can talk more about that later if folks are interested. So another punchline that we'll return to later in this presentation is that an important conclusion from the report is that these aren't ideas that are meant to be introduced just at the upper grade levels, middle school and high school, but rather that there are forms of these ideas that can help students to start to think maybe to connect back to what Lauren said, start to think about data in a more flexible and modern way, even from a young age. Start to think about computing and how it overlaps with what they're doing in science from a young age, as young as at the kindergarten grade level, not necessarily something that's left for later. And there's probably insufficient attention given to these ideas in current elementary schooling. This is probably not a surprise to anyone here. So again, Janice and I are principally science educators, but there are definite ways in mathematics education that we called out in the report and that we can recognize too, including measurement, which my second grader was just engaging in, which I was happy to hear about, both estimating and using measurement devices. Um, Thinking in terms of quantities and manipulating quantities, that is to say algebraic thinking. Some very foundational, let's say, ideas around probability. Obviously, that can get quite complex with calculus and so on. And even modeling the world with data, which is absolutely something that can be taught at all K-12 grade levels. And that these could be enhanced by more explicit connections to data and computing, not taught as isolated mathematical skills, but as a part of processes back to the foundational competencies of answering questions, solving problems, and kind of the toolkit of ways that we do that. And in science education, there are many connections both to what Lauren mentioned, the science and engineering practices, analyzing and interpreting data, using mathematics and computational thinking, developing and using models. We all know these well. There'll be a quiz at the end. Of course, we all would pass that. But also some of the cross-cutting concepts. And so, yeah, I don't think I will take this as a chance to say, I don't think there's an agenda. There wasn't. This was never mentioned that like these are meant to like replace or supplant the existing science and engineering practices or the cross-cutting concepts. But I do think there are ways that they could maybe inform a revision effort, whenever that might be. It's going to come at some point. Who knows when? You might know better than I do. And explicitly bringing these competencies into science standards and then eventually into science learning could help students to do science and to think as scientists in ways that connect more naturally to the way science works today.
Yeah.
I have lost my slide numbers, Janice, which is why I'm struggling on
Oh yeah,
my,
this
is
is
this my,
me. Yeah, this is
okay,
me.
great.
Yeah,
Would you like me to, I'll
I'll
stop sharing.
replace
Here you go.
current share. Yeah, I'm good.
Thank
Yeah.
you.
All right, thank you. So, all right, so now, oopsie, went right to the beginning. Whoops.
Did the same for
Okay.
me.
So now we talked about the foundational competencies. We've talked about how they connect to math and science in particular, the STEM areas. And now this is a shift. Chapter 5 is now thinking about how do we create these learning experiences in the classroom and why. So chapter 5 really covers this whole background that we now know about learning, about what we know about learning and learners, how can we design the learning experiences in a way that is aligned with what we know about learning, and then thinking a little bit about technology integration and tools. So think the big takeaways from chapter 5 are really that experiences need to be, connected to students' lived experiences, to their schools, to their communities, and they can be co-designed in meaningful ways. And all of this can begin in elementary school. So foundational learning can start early and then building progressively through secondary school to develop basic data and computing literacy. And if you dig into the chapters, you're going to see we cited a lot of research over the past decades. All of this is based on the evidence what we know now, and so that we can build on this moving forward. And I would say, just based on what Josh said and what Lauren's question is, I would say when I went back to read the K-12 science framework through the lens of these competencies, it's like, oh, it's all there. The parts about data, they talk about computational biology and computational science, like it's all there, but it's a matter of like what Josh said in his previous slide, like elevating that and really bringing that to light so students can make those connections and they're not seeing them as so disparate, right? The other thing about technology and tools that Chapter 5 highlights is the value of unplugged learning. So when we think about things like computational thinking, there's been a whole body of research around unplugged learning and how that really helps make some of these computational concepts that might be abstract more concrete, but then bridging those unplugged concepts to the plugged, so they're able to make that transition. And it's really important in those early grades to develop that conceptual understanding of like, what is a loop? What's a conditional? What does it look like? What is it? And how do we transfer that to an online environment, or plugged environment? And remembering that Gen AI is already in classrooms, and we recognize that, it's being used. But what does this present? It really presents that perspective that we can have these deeper discussions, and connecting to that foundational competency around technology and society. So what is the impact of these tools? How are these tools working? What are the ethical issues, the societal impacts, and then really considering how to evaluate the AI outputs. Another recommendation is to recommendations around how do we add and integrate. So really push, highlighting that state and local agencies need to really be considering how to enhance, not replace, foundational math and science learning. This is really essential to getting to the foundational competencies and to building an equipped data and computed literate citizenry. Thinking about integration again. So prioritize materials and experiences and learning experiences that help students see those connections, that they see the connections between data, computing, math, science. So, I have a really beautiful experience where I've been doing I have a data science grant here in Arizona, and I've been working with K-5 teachers. And one of the teachers that's been coming in is a math coach. And we were talking about CodeApp, if you're familiar with that environment. So there's that simulation of the seals migrating. And so he introduced that to some students through the lens of data, data literacy and making meaning of the data. And one of the students was like, oh my gosh, we did this in science class. We talked about the seals migration in science class. And so it's just wonderful when like we do that and the students make those connections. And so just more of those moments I think will be really meaningful for students. We also want to make sure to start in kindergarten, really thinking about intentionally how do we build that impact. And a lot of, again, I've been working with these teachers and it's been awesome. So we've been actually connecting, data literacy with all sorts of other things happening in kindergarten. And the teachers actually have started to integrate it in so many ways that they never had previously, particularly even visualizing data from the early years, as Josh mentioned, I think with his daughter, or thinking about then assessing how these might affect graduation requirements and how they're not, they are designed to strengthen again and not displace any science and math learning. And so putting on almost this lens of like looking at things through the foundational competencies, so we are seeing those connections and in turn designing meaningful learning experiences as such. So along with chapter 5, we have chapter 6. So how do we build a coherent K-12 approach? So when we're thinking about designing of the curricula, there's limited room, as we discussed at the very beginning, limited room for new standalone courses. So thinking about a more the landscape that we have and really taking integration as the route and integrating these foundational competencies into what's already existing. We don't talk a lot about social science, but really thinking about just across the curriculum in science, in math, throughout. And then thinking about, and then chapter 6 also includes several multiple concrete examples to illustrate how this can work in K-12. So thinking about then that we can use the foundational competencies to design learning objectives. So we can center around problem-based or project-based experiences that students find meaningful. Then we are integrating what we know about learning, but then also the foundational competencies. We talked about the ethical reflection, and that hits on the technology and society. Thinking about then again the plugged and unplugged, integrating that. And then again, making those connections to out of school spaces as well, really strengthening those connections, strengthening what we know about how students learn best and how they find things most meaningful. Chapter 7 then moves on to Lauren's earlier question, which is how do we prepare and support teachers? They are an essential part of the landscape and the ecosystem. So how do we begin to build capacity for data and computing for this type of instruction grounded in the foundational competencies? So we recognize and acknowledge in this chapter the gaps that are existing currently for K-5. It's not well articulated. So there's much work needed to guide elementary teachers. There is in-service development happening, but it's in pockets. It's not widely available. So recognizing again the point that Lauren brought out, we need to, address this in terms of like resources and support. Pre-service teacher programs, how do we address these gaps in data and computing? How do we build the teachers' skills, knowledge, confidence, and across these competencies? Thinking about supporting teachers, how does that look? We might need to think about tailoring that professional development to model this integrated approach. We might need to expand pre-service specialization pathways, maybe partnering with some of the computer science endorsements and pathways programs that are happening. A lot of work is happening nationally around transforming math pathways. And so thinking a lot about leveraging, what's happening in the ecosystem at large. And then thinking about pre-service teachers and what they might need as they enter the classroom into this world, and what kind of data and computing fundamentals might be really key, regardless of what grade level or subject area. And then when we think about elementary teachers, the fact that they're teaching all subjects, we really need to consider their particular needs. And then thinking about, is this you, Josh, or me? I think this is.
I think this is whatever you like, Janice. Flex.
Okay, I could keep. Is it you?
I think this is you, and I think I'm in the
Okay. Okay, they close. Okay,
starting scene.
so
Yep.
so chapter 8 is about transforming the system. So we started at the very beginning of the report talking about the messy garden, talking about all the different organizations and efforts underway and the need for this report. And then we come to the close of the report where we have talked about the competencies, how to design these learning experiences, what this means for teacher prep, what this means for professional development. So then we come to chapter 8, which really talks about transforming the system. This is really going to require a system shift. We need to be thinking about national and state level. To Lauren's point, what does it look like in terms of coordinating standards, revisions? What does it look like in terms of policy? What does it look like in teacher certification, aligning across the sectors? What does it look like at the local level where we have, administration, instructional support teams, curricular materials adoption? What does it look like in terms of supporting and engaging families and communities as partners in data and learning about data and computing? There's a lot of great work already done in the computing community around like family code nights and, data, data in the community and informal science. So making those connections, and again, to out of school time. There's a lot of library and community programs, and those can be really powerful learning spaces as well. So it is complex, and we recognize that. We recognize that a coordinated approach is needed, and we just point out, that there may be policy changes needed, that things like shifting the whole, teacher learning landscape may take time, and we recognize that. So Again, it's really important to measure participation and outcomes. We point that out, highlighting again the coordination needed and the investments needed. The investments needed to come together and provide coherent support. That it's really going to be focusing on supporting the system as a whole around curriculum, professional development, technology, and ways that are aligned to these foundational competencies so that, again, these connections are elevated across all the layers. And then we also talk about the need to select technology tools responsibly, particularly thinking about accessibility. We want to really think about digital and physical accessibility, investing in effective tool use and integration. And we point to a lot of evidence base, a research base of some examples of how this can be done and how can we extend this work. And thinking about really being wise in our investments to really make sure that there's enough for those upgrades and support. We want to think about clear policies on data access and student privacies. And again, revisiting those professional societies, thinking about how can we revisit those frameworks maybe, how can we elevate the foundational competencies and signal to the field that it's really it's an urgent need to really think about the coherence and connections to make sense of learning for teachers and students. All right.
Janice, do you mind, just because there's only 3 more slides in the concluding remark, would you, thank you so much. These are a high-level summary of what Janice just shared. So broadly, the kind of key takeaway or recommendation rather is to integrate the competencies into existing courses. The second, I think, relates to what we talked about regarding potentially thinking about what this means for standards, so elevating connections to existing STEM content. That can be both ways. We can use the foundational competencies to highlight what's already there, but then also we can potentially use the foundational competencies as a grist to think about what changes might need to be made to existing STEM standards and content. These should start in kindergarten, as we mentioned. Moving into the second bucket in terms of supporting teachers, we probably need to think about high quality instructional materials for both digital and not digital ways of teaching these competencies. And we need to think about pre-service and in-service professional teacher preparation and professional learning opportunities. As Janice mentioned regarding this being complex, there are a few things to call out regarding transforming the system is to catalyze some kind of data collection effort regarding which students have opportunities to engage with these ideas at what grade levels and where. The coordination piece, and then investments that emphasize not just the highest achieving or most well-resourced schools, but also all students in all American schools having chances to engage with these ideas across the K-12 spectrum. Some kind of key questions for folks, including those of us here, have to do with how, so these are foundational competencies. In some ways, they're super high level, like super high level. Those of you very familiar with NGSS know that these ideas can be can and must be vertically connected over the K-12 grade levels. And so a key question has to do with how. How might students develop increasingly sophisticated ideas about these over time? Related, what does kind of the course sequence look like in terms of these ideas, in which courses, in what structure over time? And then what are some professional development models? And then lastly, specifically, I think I'd flip this maybe and say, what are the implications of increased emphasis on data computing for the science curriculum? In some ways, it's less of an obvious connection as to the math curriculum, but I think we could make a strong case for data and computing being essential to the modern science curriculum, and there being the need for thinking about the implications of the report on our science teachers and learners. Lastly, in conclusion, Janice, do you mind to increment one more? We are very aware that education is a complex system and that we don't want to add one more thing, which is the classic mistake of um, many in our position. And so we're being mindful of that. We think that these already exist in many ways, but there is the need for more careful and kind of formalizing of what these look like in order to ensure that students have better opportunities to think about data and computing and to develop skills with data and computing. Three ways that the report calls out to do that are to make these, again, connections more explicit, to deepen connections in our content area and in mathematics, and to start these experiences to design instruction, support instruction, develop curricular materials, support teachers to teach these ideas at younger grade levels, starting in kindergarten. The report can be downloaded for the great price of free at this link. You can also use your phone to find it there. And just back to what what Janice you mentioned earlier. This was the work of a really awesome committee, and so thank you. Just want to give credit to committee chair Nick, Carrie Brenner, whose name is not listed here, but she was um, the staff member through National Academies who led the report through its conclusion. Amy Stevens initiated it. They're both just brilliant thinkers, and then the entire committee as well. And thanks, Janice, for thinking of this, and thank you all for engaging with the workshop webinar.
Thank you,
Webinar
Josh.
workshop. You're welcome.
So we have another time, a good chunk of time now to take some additional questions, have another conversation. We kind of paused after the foundational competencies, and then we spoke a whole bunch about the rest of the report, which is like kind of implementation considerations. So wondering what your thoughts are right now. What are you thinking about as related to any of the things we talked about, you know, designing learning experiences, implementation considerations, teacher training, pre-service, in-service, policy. What are your thoughts? What are you thinking?
Madam, please explain that term messy garden.
Oh, messy garden. Yeah,
Mhm.
so that was an analogy that we talked about that there was a lot of things already growing in many fields, like in computer science education. Lauren mentioned some work around computational thinking in science, and Mandy's been working in that field. Josh has been doing stuff in data. And we've been doing things in science education. There's a lot of work in math education. So all these organizations, all these disciplines, they're all growing things, right?
Okay.
They've been growing their practices and they've been growing different curricula and growing different efforts. And so it's
Okay.
messy because they're all sort of crossing over. And yeah,
Okay.
yeah. And then this was an
Thank
effort to
you.
clarify.
Got the idea of what is that term.
Okay. Yeah.
Mhm.
Yeah.
It was a
It
new term. It was a new term heard.
yeah. Yeah.
Good. Thank you very
Yeah.
much and very informative. Foundational competencies, very well explained. And it is a must that foundational competencies should be trained among the teachers.
Yeah.
You may be giving training for teachers, no, for these foundational competencies.
That is the that is one of the hopes from the report. Yeah.
Yeah.
That it is a future need.
Yes, yes, it is a must. It is a must.
Yes.
Yeah.
Yes. Yeah.
Thank you, both of you, Joshua as well as Janice. Thank you very much.
Thank you for joining. Lauren, did you have another question? I saw you maybe about to unmute.
Yeah, this has been really insightful, and I'm thinking on two different levels right now. So I guess I'll go with my first thought of I see that you've included a lot of different stakeholders in this already, but something I see that is missing as parent buy-in. I think that I've recently, I don't know if it's because of, algorithms and something I clicked on, so it elevates things more, but there's been um, a lot of parent concern about students and screen time.
Hmm.
Especially like a study came out like where so many students are just like watching YouTube for half the day or something, like all their different classes and like doing different things. And again, it just probably came across my algorithm on LinkedIn or whatever because I clicked on one thing, so it thinks I'm interested. But I'm just really curious. In general, I I was a student just graduating high school when Common Core kind of came out. Not to give away my age too much there, but one of the biggest things that in my at that time very limited experience with all of this was Common Core failed because the parents freaked out. Like they just didn't have the buy-in from them. And so it was all of a sudden, well, this is not the same math that I was doing with my kid. I can't do this now, or like the language arts was different and I can't support my student. So I'm curious where you see the role of parents fitting into this totally kind of new landscape of, like you said, not replacing but enhancing these sorts of things.
Yeah, I would say there is I would say a good half chapter or a section in the
Oh,
report that does talk about family engagement, and the critical role that families play in this. So yeah, we talk about the in-school and the out-of-school time, and again, we point to the research in that field. And one of the authors on the report definitely has done a lot of work in that area. So I do, yeah, absolutely, it's a critical piece.
yeah. And then my other
Yeah,
thought
Lauren, one quick
was
thought on that, if you don't mind. I think that's especially timely just given this kind of tech in schools backlash
Yeah.
that's really salient right now. I agree. And
Mhm.
as you were saying that, I was thinking I'm sure it's partially algorithmically driven, but I also think it's just an unprecedented moment in or at least in the
Yeah.
last 20 years or so in
Yeah.
terms of technology in schools being seen on net more as a negative than a positive, where 15 years ago, like there were these very widespread one-to-one initiatives. I mean, they're still pretty common. Whiteboards in every school, more screen time seen as a solution to educational problems. Now it's seen as, like you said, a source of distraction and other negative things. So I think that's really relevant to this report, especially because we're kind of arguing for more of the I mean, data and computing overlap with technology in schools. And I guess one last thought on that is the report does call out that like educational technologies are different from learning about data and computing. There's obviously a lot of overlap in that you can use an educational technology like Scratch to learn about computing, for instance. But you can also use an educational technology to access YouTube and look at these weird YouTube videos. So I think there's a fine
Right.
line there to be really thoughtful about in terms of how we're communicating about the report. We're not saying more technology necessarily. So that analog piece is really important. So good point. I'll think more about that. I do think science educators have done a better job than Common Core in terms of not
yes.
eliciting backlash. Like it's in some ways surprising because in some ways the science standards are more culturally loaded with natural selection and environmental science and climate science being part of them. But yeah, so
Yeah.
very astute points taken.
Well, and two, you
I'll
guys
just add.
prioritize. Oh, sorry.
Oh,
I was
oh,
gonna say
no, I
the
was,
unplugged and plugged in
yeah,
digital
yes, I was
nature. So the
exactly.
unplugged, yeah,
Yeah, I was literally just
yeah,
gonna say that. Yeah. So I think the other thing is just the intentional design, and I think going back to like active learning and what we know about how, learning happens,
Mm.
I think that's really intentional. And then again, if we're focusing on things like in the foundational competencies of like using it to solve problems, to solve things in their community, I think that will shine through as like really valuable.
yeah.
Yeah. A
And
really
then
good
I was
point.
just gonna say
Hmm.
the other thing that I was thinking about is like when we were thinking about dissemination of these sorts of things or how these things get out, like just the number of partner agencies I think that y'all are working with is really important. So I appreciate that just in general. How many people you're trying to reach.
Oh, thank you. That's great to know. Yeah, yeah, we're trying. So,
I actually do have to go, but I super
okay.
appreciate
Thank
this
you.
and appreciate all of your time.
Thank you. Thanks for
Thanks,
joining.
Lauren.
Yep.
Yeah, I'd love
Have
to
a
stay
good
in
one.
touch on these topics.
Yeah, that sounds great. I will probably send both of you a LinkedIn
Please do.
invitation.
Yeah,
Yeah,
Sounds great.
that'd be
absolutely.
great.
Or
Thank
email.
you.
Yeah. Thank you. Mandy and Sarama, if we have a few more minutes, if you have any questions, comments.
Well presented, madam.
Okay, thank you.
Thank you very much for this presentation. And what is the time there now?
It is almost 9 a.m.
Almost
Mhm.
Almost 9 a.m. Yes.
9 a.m. Okay.
Hi,
Yeah,
Mandy.
thanks, Sarama. Thank you,
Hey,
Mandy.
sorry, I was feeding the baby, but I was listening the entire
Yay.
time.
How old's the baby?
She's like 4.5 months now.
Oh, fun time. Fun time.
Yeah,
Wonderful. Wonderful.
yeah.
Well,
Well, I think you guys did a lot of really great work, and I really like the combination of all of these ideas, and it's something that definitely resonates,
yay.
um, with what I'm trying to do too.
Yay.
And it'll be nice to have the report as something else to point to, I think.
Yeah.
Uh, as like, look, this matters.
Yeah. Absolutely. Yeah.
Like I was the discussant on that Open SciEd
Oh, cool.
um, session that Lauren talked about, and it was just like they, did some good stuff, but largely ignored the research that had already been done in that area.
Hmm.
And it was kind of like trying to reinvent the wheel when so many of us have been working on this stuff for a while. So there's so many different like language entry points. Like, are we talking computational thinking or computational modeling, or is it data? And so, like, sometimes even when you're trying to find resources and what's already been done in integration, it can be challenging. So having it like all in one spot, like this report, I think is an important step to like making it known. And I, really like the idea of like stuff is already happening and how do we build on it?
Yeah, well, thanks for sharing that, Mandy. Tiffany Neal, she came to the AERA session that we did on this report, and I think she must be involved in that Open Science Ed work that you're mentioning. Do you know Tiffany? Was she there at
Yeah, she
Next?
was not at the session, but I know that
Okay.
she was a co-author on one of the papers or two of them.
Okay, cool.
Yeah.
Um, cool. Would love to discuss sharing. Um, I mentioned this earlier, but yeah, how we can share this with the science ed community.
Yeah.
So Janice and I are discussing a few options, including yeah, we're just open to different ideas, including a Jarst commentary, which is pretty short. Those are like 1,000 words, so that would basically have to be
Cool.
very clear on like what the punchlines are. Maybe room for one
Yeah.
punchline.
Yeah.
Um, talking about NSTA articles, possibly. Talking about some other things. Janice has an idea for a chapter potentially in a handbook, which would have more space. Um, that's the Janice. That's the Handbook of Research on Science Teacher Education. I think that's a pretty prominent potential venue to share in.
Yeah.
Yeah, that'd be great.
Well, thank you all for joining. We'll be in touch. And a lot more work to do. So it is great to have the report, but it's also as Mandy said and Josh said, there's a lot more work to be done. So I think we'll definitely continue the conversation.
Sounds good. Thank you, Janice, and thanks, Mandy. Thanks for
Thank
presenting.
you. Thank you
Thank
all.
you.
Thank you.
Okay.
Thank you.
Thank
Have
you.
a great day.
Bye.
Bye bye. Bye bye.